Hi, welcome to CEC 2021 and to our session titled Use of Progress Monitoring Data to Improve Instruction. Why is it so difficult? My name is Jessica Toste. I'm an associate professor in the Department of Special Education at the University of Texas at Austin, and I'll be presenting with my colleague, Dr. Christine Espin, who's a professor in the Department of Education and Child Studies at Leiden University, the Netherlands. We're going to start today with a brief overview of database decision-making and how it works and why it's so important. And then I'm going to talk about one study looking at interpretations of progress monitoring graphs. I'll then switch over to Chris, and Chris is going to talk in more detail about why database decision-making is so difficult. We'll end off with some questions and considerations for you to think about after you watch this video. So database decision-making, if we think about reading and literacy, we know that it's a critical social issue. It's critical not only to academic achievement and what happens in our schools, but literacy is highly related to economic growth, public health, and we know that students who struggle with reading are at risk for continuing to experience difficulties throughout their school years and beyond. In the United States, about 2.3 million students are identified as having a specific learning disability, and the most common type of learning disability is in the area of reading. This group of students represents the largest population of special education students in K-12 education. Amongst this group of students, we have excellent interventions to support students' reading growth, but not all students respond to standardized, high-quality, research-based reading interventions. We estimate that about 5% of students require more intensive intervention. And so when we think about intensive intervention, we may think of that as a different kind of program or something that has some other component in the program. But we know for this group of students who require intensive intervention, there's no silver bullet program that's going to meet the needs of all of their learning needs. And so research-based instruction needs to be adjusted for students, and it needs to be individualized. The content can be adjusted, the grouping can be adjusted, or the dosage of the intervention can be adjusted. And these adjustments to interventions must be data-driven. And so we use data to make really good decisions about how to intensify and individualize interventions. This process of using data to intensify and individualize interventions is called DBI, data-based individualization. And DBI is a systematic method for using student data to determine both when and how to adjust or intensify an intervention. This model is from the National Center on Intensive Intervention, and it talks about the process of DBI. So it goes through what's called phase A, the setup phase. So this is where a teacher would select a validated tier 2 supplemental intervention. They would make initial adjustments to that intervention based on the needs of the student. And then they would decide how they're going to monitor that student's progress. They would choose a curriculum-based measurement, CBM, to measure their progress over time. They would administer that probe frequently. It's very brief, so it can be done regularly. And then data are typically put onto a line graph to show students' progress over time. The second phase of DBI is the individualizing intervention aspect. So when using the student's progress monitoring graph, we would determine whether an adjustment is needed. And if so, we'd collect diagnostic data to understand how to adjust that student's instruction and what they might need. Then we'd implement the adjustment and repeat over time. So if we show kind of a summarized version of this model here, we see we implement an intervention, we monitor progress, we decide whether or not a student has been adequately responsive to the intervention, and then we make adjustments from there. So this aspect of the DBI model is what we're going to focus on in our presentation today. This part of intensive intervention where a teacher has to decide whether or not a student has been adequately responsive to the intervention and whether or not they're going to make an adjustment. And so it seems like a fairly easy decision. Has the student been making progress? Yes, no. I'll talk a little bit about how we decide this and then get into talking more about that specific decision teachers need to make. So in order to make this decision, has a student been adequately responsive? Yes, no. Do I need to adjust instruction? Yes, no. We would put CBM data on a progress monitoring graph. So this is a sample progress monitoring graph with ORF or oral reading fluency data. And so this graph shows student data across 14 weeks of intervention. You can see on the graph that the number of words read correctly, so each of the weekly CBM probes is represented by one of the blue dots. The goal line, which is the bold orange line across the graph, shows the expected or desired rate of growth for the student. And then the slope or the trend line is the blue dotted line. And that line shows what the student's actual or current rate of growth has been. And the way that we make a decision with this graph is that we compare the student's actual rate of growth, so that trend line, to their expected rate of growth, the goal line, over time. And if the actual rate of growth is lower than expected, it's an indication that the student's instruction should be adjusted. There are some other decision-making rules that also come into play here, but this is essentially how we compare actual rate of growth to expected rate of growth to decide whether or not a student has been making adequate progress. So it seems like a pretty simple decision, right? You look at the student's data and you decide whether or not they're making expected growth. Turns out, it may not be as simple as we think. I'm going to share one sample study where we looked at graph interpretation with pre-service teachers. So past research on graphs have looked at teachers' decision-making based on a complete graph. So they've looked at a graph similar to what I just showed you with 8 or more weeks of data, and they've sort of done a reflection of what has been happening in that student's intervention, have they been making adequate growth, and would the teacher make an instructional adjustment? So in this particular study that I conducted with colleagues at the University of Texas at Austin, we wanted to investigate the decisions that teachers made based on progress monitoring data that was presented sequentially, which means the teachers would see one data point at a time, like we would in real life when you're collecting data with a student. So in the study, we had 33 participants. There were majority female identified, 3 male. Just over 50% of our sample were white, and then there was a distribution across other groups. And all of our participants were currently enrolled in a teacher preparation program. And they were in the later years of their teacher preparation program. So they had taken at least their primary classes on reading intervention and special education methods. In the sessions that participants completed, they completed a demographic survey where we asked questions about their coursework and training on data-based instruction. We asked about their self-efficacy and data decisions, and we did a simulation activity. So I'm going to focus on talking about this simulation activity. They looked at 4 different cases and answered questions about students' data in each of those cases. So first, I'll mention briefly how we came up with these cases. We generated hypothetical data for hypothetical students. We started by students having an estimated 2 words per minute gain per week in oral reading fluency, with a goal of about 112 by the end of the school year, the intervention. And then from there, our data points were randomly generated for each case based on hypothetical rate of growth and variability. So we ended up with 4 cases. In case 1, this represented a student who was on track to make progress. Their data were less variable, and there was an outlying data point, as you can see right here. Second case was a student who was not on track to meet their goal by the end of the year, and the data were more variable. Case 3 was another student who was on track, but their data were more variable. And case 4 was a student who was not on track to meet their goal by the end of the year, but their data were less variable. The data points were closer together. So the data simulation activity started the same for every participant. We just told them simply, we're going to look at 4 student cases. All of the students in these cases are 3rd grade boys identified with a reading disability, and they all have similar academic profiles. All of these 4 students you're going to see the graphs of are receiving supplemental reading intervention, so tier 2 reading intervention, and their progress is being monitored once per week with a measure of oral reading fluency. Each case that participants looked at represented 10 weeks of data for 1 student. We conducted a brief overview so participants would know what they were looking at. So we told them you'll be asked to look at a student assessment data on a graph like this, that they were looking at oral reading fluency, which represents words read correct per minute at each data point. And then we had a very quick tutorial where we showed them this, as indicated on the chart, this was the baseline, so the data that was collected to measure performance prior to the intervention starting. This was the student's goal, so where we wanted them to be at the end of the intervention. The goal line was represented with the orange bold line. That was their expected performance. The data points were circled here, and that was their weekly oral reading fluency assessments. And then the trend line was the blue dotted line, and that represented their observed performance over time. So then we got into showing participants data points sequentially. So we said, you'll see a series of slides in which data will appear as if you're collecting it week by week. After each data point, we'll ask you how you interpret the data. And participants were asked to answer after each data point, would they continue the intervention? Would they make a change at this point? So do they have enough information to say they would make an adjustment? Or they could also say, I don't know. And I don't know, we very clearly indicated that this was really that, not that they don't have enough information, but they truly did not know how they would interpret the data at that point. So I'll walk you through one case to show you how participants responded and what the simulation looked like. So this was case study number 1. We would present the first data point. And here we had 3 participants who said right away that they would make a change to the instruction. The second data point, we had 2 participants who said they would make a change. Third data point. The fourth data point, you can see there's a little bit of dip in the performance, and we had 16 of 33 participants said that they'd make an adjustment at this point. Then number 5, 2 participants said they would adjust. 6, 5 said they would adjust. The 7th data point, we had another little dip in performance, and 22 of 33 participants said they would adjust instruction here. Went up a little bit. We had another 3 who said they would adjust instruction. And you'll see on some of these, I've indicated some participants who said they didn't know at this point. And then 17. And on the last data point, we had 1 participant who said they would make a change. So I'll summarize this so that you see how participants responded across each of the cases. So the sequential data that participants saw, this was case 1 that I just walked through. And the data here, as you may remember, as the student was on track to meet their goal, the data were less variable, and there was that outlier data point. And so the summary here was that participants, at least 1 participant said they would make an adjustment at every data point. At this outlying data point, which was week 7, you see we had the largest number, 22 participants of 33 said they would make an adjustment at that point. Case number 2 was when the student was not on track to meet their goal by the end of the year, and the data were more variable, which means performance kind of went up and down from week to week, which is very common among student data. So across all of the data points, we had participants say that they would make adjustments except for week 1. And you can see that the numbers were quite a bit higher than in case number 1. So we had quite a few participants saying they would make changes at every one of these data points, likely because, as I mentioned, the data were more variable. In case study number 3, this was the student who over time was on track to meet their goal, and their data were more variable. So there were some weeks where we had no participants say that they would make any instructional adjustments, but in the other weeks we did have, in week number 4, right here, we had 15 participants say that they would make an instructional adjustment. And in week number 9, which is the second to last data point, we had 23 of 33 participants say they would make an adjustment. And then finally, in the 4th case, this was a student who was not on track to meet their goal, and the data were less variable. So you can see the data points were closer together. And we had participants, again, say they would make adjustments across all of these data points, with a large number of participants saying they would make adjustments at week 3 and week 5 and then again at week 7. So the next thing we did is that we were interested in seeing if participants' responses would change when they were looking at graphs sequentially. So when I look at data week by week, like I would with my own students in the classroom, do I make different decisions than if I looked at a complete graph for that student? And usually we have more information. We can look back and in retrospect and say where we should have or would have made an adjustment. So we showed participants complete data graphs and asked them, would you have made an instructional change for this student? And if so, when would you have made that instructional change? We didn't tell participants that these were the same graphs that they had just viewed for the 4 previous students. So we just told them these were 4 complete graphs for students, and they actually mimicked what they had just looked at sequentially. So in case number 1 here, you can see that we had some participants said they would not make any change for this student. And across that, there was a lot of distribution of where participants said they would make a change, with most participants, 11 of the 33, saying they would make an adjustment where we saw that dip in performance, the outlying data point. For case number 2, this was a student who had more variable data, and we saw that participants said that they would make an instructional adjustment, but it was very different in terms of where they determined they would make that adjustment. In case number 3, we had a number of participants who said they would not make any adjustments for this student, but others said they would, and they sort of, the performance, the decision of where they would adjust differed based on student performance. And then finally, in the 4th case, we had participants say they would make adjustments, and they differed considerably in terms of where they decided they would have made that adjustment. So the next thing we're working on, which I have not showing you right here, is actually coding all of the participants' responses, because another thing we asked them to do is that they said they would make an adjustment to talk about their decision-making process, why they were making that adjustment. And so right now we're coding the transcripts of participants' answers to see what kind of information was used most commonly to make decisions. But of what we found so far from reading those transcripts and looking at this data that I presented is that there is not a lot of consistency in decision-making rules that participants are using. And that's true both within a participant and across participants. So I would use a decision-making rule, and I might not use that consistently every time I make a decision. And the same is true that myself and my colleague are using different kinds of rules or assumptions around how we make decisions. The next big thing we found is that there's more difficulty interpreting variable data and data that has outliers in it. And so when we see data or performance kind of move up and down a lot over weeks, it becomes more difficult for us to make a decision with confidence. And the tricky part about this is that student data does tend to be quite variable, especially students who have reading disabilities. So the data that was tighter tend to lead to more confident decisions. And many of the participants noted the variability in the data, but they interpreted this variability as the intervention not working, rather than needing to wait more time to see how the student was performing. The other thing that was interesting is that participants gave very different responses depending on whether they were looking at sequential data week by week or a full completed graph. And sequential data led to participants making earlier instructional changes. So you saw from what I presented, a lot of participants said even in weeks 1 or 2 that they already would have made instructional adjustments. So that's a brief summary of how teachers, in this case pre-service teachers, would look at a graph and think about how they would make that very simple decision, or what we assume to be a very simple decision of would you adjust instruction, yes or no. And so I'm going to turn it over to Chris to talk in a little more detail about why that decision is so difficult.
Thanks, Jess. I really enjoyed the beginning of the presentation. It's a nice introduction to my part of the presentation. And my name is Chris Espin. And as Jess said at the beginning, I'm at Leiden University in the Netherlands. And I'm going to talk about why is it the database decision-making is so difficult for teachers. One of the things we know about the effects of implementing database decision-making is that if teachers respond to progress data with instructional decisions, the way that Jess was talking about, student achievement improves. Unfortunately, we also know that teachers often do not respond to progress data with instructional decisions. In other words, they may see that a student isn't doing well, but then they don't do anything to actually change their instruction. We were interested in answering the question, why? Why do teachers have so much difficulty making instructional decisions? So in our research, we addressed the second part of the title, why is it so difficult for teachers to use data to make instructional decisions? And we wanted to specifically know, is it just a teacher problem? And so we began by going to the literature on decision-making and on graph reading. And upon reading the literature, we came up with two potential reasons for why teachers may have difficulty with database decision-making. The first reason is that using data to make decisions is in general difficult. And the second is that reading simple graphs is not always so simple. I'm going to start with the first. Using data to make decisions is in general difficult. One of the assumptions of database decision-making is that humans are rational in their decision-making. In other words, the assumption is that when we have to make a decision, we gather all the necessary data, we consider all possibilities, and then based on that information, we make a rational, logical decision that's based on the data that we have. But how rational are we in our decision-making? Or more specifically for us, how good are we at actually using data to make decisions? Let's try it. I'm going to put you to work. I'm going to show you a simple math problem and give you a few seconds. Go ahead and read the problem to yourself and then write your answer down. You ready? Okay, here's the problem. All right, I hope you had time to read through that, write your answer down. What was your answer? If you, like many others, wrote the answer as 10 cents, you're actually incorrect. The answer is not 10 cents. Remember that the question said, a bat and ball cost $1.10. The bat costs $1 more than the ball. How much does the ball cost? The actual answer is 5 cents. The ball costs 5 cents. The bat costs $1.05. Thus, the bat costs $1 more than the ball. This problem is often used in the decision-making literature, as well as others like this, to illustrate the fact that humans are not necessarily rational or logical in their decision-making. In other words, we often do not use all available data to make our decisions. And we're biased in our decision-making. We only attend to a limited selection of data. Herbert Simon, who did a lot of work on decision-making, referred to human decision-making as bounded rationality. He said, well, human beings are actually rational, but within human limitations. In other words, when we're making decisions, we have a limited amount of information, we have limited time, and we have limited capabilities. For example, we can only hold so much information in our working memory at one time. Simon said it would be better to talk about human decision-making as satisficing. In other words, that we only consider different alternatives until we find one that is satisfactory. And once we find one that is satisfactory, we stop searching and we implement our choice. He also said we use heuristics when we're making our decisions. And heuristics are simple rules that allow us to make decisions with very limited information and with very little effort. An example of a heuristic that humans often use is called a representativeness heuristic. This is a heuristic or a shortcut in which we recognize and respond to a pattern of cues that look like or is representative of the prototypical example of a situation. And the bat and ball example is an example of a representativeness heuristic. In other words, we are really used to answering simple math questions like a bat costs $1, a ball costs, the total cost is $1.10, what does the ball cost? We overlook the part of the problem that says $1 more than the ball. So this is an example of us responding to a pattern of cues that we are used to that looks like other problems that we're used to, and then answering based on that. So if we go back to answering the question, how good are we at using data to make decisions? From the decision-making literature, we would have to answer that as human beings, we're not all that good. And so maybe you're then asking yourself, well, why do we expect teachers then to easily use data for decision-making within database decision-making, DBDM, or within DBI? Let's go to the second part of potential reasons why teachers have difficulty with database decision-making. We also looked into the graph reading literature. And what we found was that reading simple graphs is not always simple. Jess had talked to you about graph reading for her pre-service teachers. We did a study where we wanted to ask how well do in-service teachers read and interpret CBM progress graphs, the kind of graphs that Jess had shown to you. And so we did this study on teachers' comprehension of CBM progress monitoring graphs, and the lead researcher was one of my doc students, Roxette van den Bosch. The goal of our study was to examine teachers' ability to comprehend CBM progress monitoring graphs. And by graph comprehension, we mean the ability to read and interpret data in a graph and to link that data to the instruction. And we wanted to know whether or not, if teachers had difficulties, whether these difficulties were unique to teachers. So we compared teachers' performance with 3 types of gold standard experts. Who were these gold standard experts? We had 2 statistics experts, 2 educational experts, and 3 CBM experts. And we used the data from the gold standard experts to give us a kind of an idea of what we might expect from teachers if we compared their performance to that of these experts. Our statistics experts were assistant professors in statistics. Each had 10 years of experience in teaching statistics. They had a PhD in psychology and statistics, and their expertise was in general graph reading because they had read and interpreted hundreds of graphs. Our educational assessment experts worked for a Dutch national assessment company in which they developed progress graphs. They had PhDs in educational psychology or in statistics and psychology. And their expertise was reading educational progress graphs, but not curriculum-based measurement graphs per se. And then finally, our CBM experts were professors in special education who had PhDs in educational psychology and special ed, had 30 years of experience in research and training on curriculum-based measurement, and their expertise was reading CBM graphs. Our teachers who participated in the study were 23 teachers in grades 5 to 8 from 13 schools. They monitored the progress of 2 to 4 students with reading difficulties for a period of 10 to 12 weeks. And at the end of that 12 weeks, we asked the teachers to describe both standard graphs and student graphs. And standard graphs were graphs that we made as the research team. And we also asked our gold standard experts to describe the standard graphs. And I'm just going to talk about the standard graphs today in this presentation. Here's what they look like. We showed the participants 2 standard CBM graphs. And then we asked the participants to look at each graph, so they did 1 graph at a time, and to think out loud about the graph. In other words, we said, look at this graph of a special education student's progress in reading. Think out loud as you look at the graph and tell me what you are seeing and thinking. Tell me what you are looking at and why you're looking at it. We then scored their think alouds for a couple of different things. First, we scored their think alouds for accuracy, completeness, and coherence. In other words, if you look at a CBM graph, there are 9 components of the graph that you can talk about. And we wanted to know to what extent Do our participants accurately describe those components? First of all, do they include all 9 components? Do they accurately describe the components? And do they actually describe them in a coherent sequence or in a sequential manner? So what do I mean by all that? Well, if you're actually using a CBM progress graph to make decisions, you first talk about how is the graph set up, what's on the x-axis and what's on the y-axis. What are the baseline data? Where does this student start compared to his or her peers? What is the goal? So what goal did the teacher set for the student? And then you look at each instructional phase, and you look at the data in each phase to determine whether or not the student was successful in that phase. In other words, was the instruction effective for a student in the first phase? And then when a teacher makes an adjustment, did the student do better? If the teacher adjusts instruction again, did the student improve? And then finally, you look at the last instructional adjustment, and then you talk about whether or not the student achieved the goal. So you see here that there are, sorry, I said 9. In this graph, there are actually 8 components. And we wanted to know to what extent do the participants talk about those 8 components, and are they accurate, and do they talk about the components in a coherent sequence? We also wanted to know when participants talk about the instruction in a particular phase, do they make comparisons between the student's rate of growth, which is this slope line here, and the goal? In other words, do they compare the student's data and the student's rate of growth to the goal line or the expected rate of growth? And we call that a data to goal comparison. We also want to know, do the participants compare growth in one phase to growth in another? In other words, here the student is not growing very well and the student will not achieve the goal. So the teacher adjusts instruction. Do the participants then compare the student's rate of growth here to the rate of growth after the instruction has been adjusted? And we call that a data-to-data comparison. And finally, we wanted to know, to what extent do teachers or our participants compare the student's rate of growth to instruction? So in other words, do they look at the student's rate of growth and then make evaluations of the effectiveness of instruction for that student given the student's rate of growth? And we call that a data to instruction link. So what did we find? Here you see a table, and it has the factors on the left that we looked at: accuracy, completeness, sequential coherence, and then those 3 kinds of comparisons: slope to goal, slope to slope, and slope to instruction. And these are the teacher's data, and these are on the right-hand side are the data for the CBM experts. Now, if we look here, we find that on terms of accuracy, the teachers were fairly accurate. What they said was about 97% accurate, which was about as accurate as the CBM experts. However, the teachers only talked about 6 of 9 components. Across the 2 graphs, there were 9, and the experts talked about 8 of 9 components. The coherence with which teachers talked about, so the extent that they talked about those components in a logical order, was about 43%. So 43% of what they said was in a logical sequence or order, compared to 85% for the experts. And then if we look at the number of times teachers made slope to goal, slope to slope, or slope to instruction and comparisons, you see that in general, teachers made about one of those comparisons, of each of those comparisons. If you look at the experts, they made 5 slope to goal comparisons on average, 4 slope to slope, and 5 slope to instruction. If we were to just look at these data, we would say, teachers really have a hard time interpreting CBM graphs, and they're just not very good at it. But now let's look at what happened with our other set of experts. Here you see the data for the statistics experts and the education experts. And there are a few things that pop out. First, in terms of completeness, the statistics experts actually mentioned fewer components than the teachers. Statistics experts only mentioned about 5 of the 9, whereas teachers had mentioned about 6 of the 9. Compared to the teachers, the statistics experts talked about the graph in a much less logical or sequential manner than the teachers. And the teachers were not that much worse than the education experts. So teachers had a sequential coherence score of 43%, and that was compared to 52% for the education experts. But for the statistics experts, it was only 18%. And finally, if we look at the number of slope to goal and slope to slope comparisons, we see that teachers made about as many of those comparisons as the statistics experts, and more on slope to instruction comparisons. So teachers were more likely to compare the data to instruction than the statistics experts. So if we take all of these data into account, we might say, well, teachers were not all that bad. But there were particular areas of concern. And that is these particular parts of reading the graph, making those slope to goal, slope to slope, and slope to instruction comparisons, where you see that even though teachers were better than the statistics experts, they were far worse than the CBM experts, and also not as good as the education assessment experts. And these decisions are really important, or this part of graph reading is really important because these are the essence of CBM database decision-making. This is how you use the data to actually make decisions about your instruction. So let's go back. There are 2 potential reasons for teachers having difficulties with database decision-making. The first is that using data to make decisions is in general difficult for human beings, not just for teachers. And second, reading simple graphs is not so simple because even though teachers were not as good as CBM experts, in some ways they were better than statistics experts who had experience reading hundreds, if not more line graphs. And yet those statistics experts also had difficulty reading the CBM graph. And I would just add here, even though I didn't have time to say it, we actually gave a little tutorial similar to what Jess was talking about to all of our participants. So we actually told the statistics experts before they read the standard graphs, how the graphs were set up and what the information in the graphs was. And still they had more difficulty in some parts of graph reading than the teachers. So once again, maybe you're asking, well, then why do we expect teachers to easily be able to use data for decision-making within data-based individualization if we know that 1, human beings have trouble using data to make decisions, and 2, reading graphs is not as simple as we think? Well, our answer is that we actually don't expect teachers to be able to read and interpret CBM graph data as easily. So both Jess and I are working on research that involves creating decision-making supports that can help teachers to make good database decisions. And if you have a take-home message from this presentation, I think that take-home message is that we should not expect teachers to just be able to use data to support or to make their instructional decisions, and that we, in fact, should provide more supports to help guide teachers in their decision-making if we really want the data to contribute to better instruction and better student achievement. So if I go back to the beginning slide and the title of our presentation, using progress monitoring data to improve instruction, why is it so difficult? I can say for sure that the answer is not that it's a teacher problem. It's difficult because it's difficult, and we need to do more to provide supports to teachers. Now, I just want to finish up with a few questions and considerations that we have that you can maybe think about. Here are some questions to consider. Related to what I had said earlier, why do we expect teachers to have strong data decision-making skills when humans find it difficult? Another question, What supports can be developed to facilitate teachers' use of data and the decision-making process? How do we ensure that educators and all other stakeholders understand the value of data? And finally, how do we differentiate between various types of data and the utility of those data sources? I'm sorry to say that this year we can't actually discuss these questions or consider them together as a group. It would be very nice, because I know for a fact that Jess and I would really like to hear your thoughts and reflections on these questions. But we hope that next year we'll be back with some additional data and some additional information, and maybe then we'll have a chance to discuss this information in depth. Until then, we thank you very much for your attention, and we thank you for attending our session for the Council for Exceptional Children Conference. Bye-bye. Thank you. Here's our contact information.